Hello, curious minds. Today, we're exploring a discovery that just rewrote what we thought we knew about the coldest, most distant world in our solar system. Pluto might have a hidden ocean under miles of ice. But on the surface, by every model scientists have, it should be bone dry. Too cold, too far from the sun, even after 2015 proved it's geologically active. So what happens when scientists look at that data with fresh eyes? They found something that shouldn't be there. Dark streaks that look like evidence of liquid. Not billions of years ago, recently. These streaks were studied for 11 years and explained differently every time. So is there really liquid on Pluto's surface? When New Horizons screamed past Pluto in July 2015, it gave us our first real look at a heart-shaped region the size of Texas and Oklahoma combined. A frozen nitrogen glacier called Sputnik Planitia, flowing slowly like a very cold lava lamp. That flyby already proved Pluto was geologically active in a solid-state sense. No craters on that glacier at all, meaning the surface resurfaces itself constantly. But for over a decade, nobody thought that activity involved actual liquid. Ice moving, yes. Liquid flowing, no. So what changed? In August 2026, a team led by Alan Stern, the principal investigator of the entire New Horizons mission, published a paper with a very careful, very deliberate title: Evidence for Possible N2 Basal Flow Beneath Pluto's Northern Sputnik Planitia. Translation: they think liquid nitrogen is flowing up from underneath the glacier, through cracks, onto the surface. Here's the part that surprised me most researching this. Those dark streaks along the northern edge of Sputnik Planitia weren't some hidden detail. Other scientists had already published papers on them back in 2017, interpreting them as flow lines, ice moving around obstacles or squeezing into fractures. Reasonable explanation backed by real modeling. So what changed wasn't that someone finally noticed the streaks. It's that Stern's team tried something nobody had before. They pulled Landsat 9 satellite images of Greenland's ice sheet here on Earth and compared them side by side. The match was almost eerie, nearly identical to places on Greenland where meltwater seeps up through cracks and darkens the surface. On Earth, that's meltwater. On Pluto, at nearly 40 times farther from the sun, with surface temperatures colder than dry ice, what could possibly be melting? Not rain. Pluto's atmosphere makes liquid nitrogen rain physically impossible. Too thin, too cold, the physics doesn't work that way. And before you wonder, no, this isn't the sun's doing either. Pluto's orbit is wildly eccentric, swinging from about 30 times Earth's distance from the sun all the way out to 50 times over its 248-year lap. That swing is real, and it does drive a genuine seasonal cycle. Nitrogen frost freezing onto the surface as Pluto pulls away, then thinning back into a wisp of atmosphere as it swings closer. But even at its closest approach, Pluto's surface never climbs out of the deep freeze. We're talking somewhere around -380 to -400 degrees Fahrenheit, no matter where it is in its orbit. Nowhere near warm enough to melt nitrogen from sunlight alone. If it were, this wouldn't be a groundbreaking paper. It'd be expected. So if it's not falling from above, and it's not the sun warming the surface either, it has to be coming from below. The leading explanation is basal melting. Deep beneath Sputnik Planitia's kilometers-thick nitrogen ice sheet, pressure and trapped internal heat may be enough to melt nitrogen ice into liquid, then force it upward through cracks as narrow as 15 centimeters to about a meter wide, the same way water finds its way up through a cracked sidewalk. The estimated melting zone sits somewhere between roughly 300 meters and 1.4 kilometers below the surface. But here's the honest part. Researchers aren't fully sure what's generating enough heat to make it happen. Movement from the glacier alone doesn't seem to be enough on its own. So the how is still an open question. The pattern itself, dark streaks that match what liquid leaves behind on Earth, that part they're confident about. One more piece worth sitting with. Sputnik Planitia's surface overturns fast, geologically speaking. The whole ice sheet slowly convects and resurfaces itself, wiping out old features in the process. Which means these dark streaks can't be ancient. If the process that made them had stopped long ago, the moving ice would have erased them by now. Researchers estimate the streaks formed within roughly the last million years. A million years sounds enormous. On a human calendar, it is. On Pluto's 4.5 billion year clock, a million years is basically last week. Recent doesn't mean yesterday, it means active, something that may still be happening today. Not everyone is convinced. Mike Brown, the Caltech astronomer known for helping demote Pluto from planet status, offered a broader note of caution. Everybody wants things to be geologically active, he said, a reminder that the field has a bias toward finding activity, even where the evidence is still thin. And Stern's own team isn't claiming certainty either. Their paper notes that alternative explanations, like surface frost patterns or sublimation effects, haven't been fully ruled out. Notice the title again: Evidence for Possible N2 Basal Flow. Not confirmed, not proven. Possible. Because that's what honest science looks like when you're staring at something genuinely new. If this holds up, here's what's actually new. Not that Pluto is dynamic, we already knew that, but that liquid may be reaching the surface, something that could still be happening today. And Pluto might not be the only place this is happening. Take Triton, Neptune's largest moon. Back in 1989, Voyager 2 photographed active geysers erupting from Triton's surface, plumes rising 5 miles high, trailing material 90 miles downwind. For decades, nobody had a solid mechanism to explain them. Triton is a captured Kuiper Belt object with that same nitrogen-rich surface, and Stern's own paper points to basal melting as a mechanism worth reconsidering for what Voyager saw there nearly 40 years ago. In 2024, a separate team using the James Webb Space Telescope found signs of internal heat and geochemical activity on 2 other Kuiper Belt dwarf planets, Eris and Makemake, based on methane isotope ratios in their surfaces. That's a different research group and a different method than the Pluto liquid nitrogen study. But the new Pluto paper explicitly names Eris as a strong candidate for this same kind of basal melt, given how similar its deep nitrogen ice makeup looks. So the real question isn't, is Pluto special? It's, how many worlds out past Neptune have we been calling frozen and dead, when they might just be quiet? Here's the honest part. There's a proposed Pluto orbiter, a mission called Persephone, roughly $3 billion, designed to actually settle into orbit instead of just flying past. But it's still just a proposal, competing for funding against every other outer solar system mission NASA is weighing. Nothing's been approved. And even if it launches, current mission designs put arrival at Pluto decades away. That's how far out here really is. The cracks researchers are talking about may be as narrow as 15 centimeters to about a meter wide. Features New Horizons, flying past at over 30,000 miles an hour, could never have resolved directly. So what's next isn't a launch. It's slower than that. Scientists want to run laboratory experiments on solid nitrogen under Pluto-like pressure and temperature. Physics that's never been studied in this kind of detail before. They want higher resolution mapping of the more than half of Pluto never imaged in detail at all. And they want to point telescopes at Eris and Triton with this new mechanism in mind. In other words, the next discovery might not come from a new mission. It might come from someone years from now looking at data we already have, the same way this one did. 11 years. That's how long scientists studied these exact streaks and explained them as ice, not liquid, until someone compared them to a Greenland ice sheet and found evidence pointing somewhere else. Pluto's geological activity was confirmed back in 2015. In 2026, the data suggested that activity might go further than anyone realized. So here's the real question worth sitting with. How many other settled explanations about our solar system are actually just the first reasonable guess, waiting for someone to compare it to the right thing and see it differently? If you want to see what else New Horizons is still finding 11 years later, consider subscribing. It helps me keep making videos like this one.